Hello, good morning to all students। उम्मीद करदा हां कि तुसी सारे अपने घर ठीक होवोगे। Today you are welcome in this second lecture of calculus. I am Ajinder Pal Singh. In the first lecture, we have discussed what is real numbers. I am just revising the previous lecture. In previous lecture, we have discussed what is natural numbers, what are integers, rational numbers, irrational numbers, and then real numbers. 1, 2, 3, and so on. These numbers are called natural numbers. Set of natural numbers is denoted by capital N, and so on. -3, -2, -1, 0, 1, 2, 3, and so on. All these numbers are known as integers. Set of integers is denoted by capital Z or capital I. And then we have taken rational numbers, a number which can be put in the form P upon Q. P and Q both are integers. Denominator Q not 0, and GCD of P and Q must be 1. So a number of this form is called a rational number. Set of rational number is denoted by capital Q. Next, we have taken uh, irrational numbers. A number which is not irrational is called irrational numbers. And lastly, we have taken real numbers. What is real number? All rational and all irrational together, they are called real numbers. Set of real numbers is denoted by capital R. So today we will discuss some properties of real numbers. Okay, so today our lecture is field of real numbers. In this topic, we discuss properties of real numbers under the operation addition and multiplication. First, we will take the operation addition. Now here is a first property under addition. The meaning of this property is if we choose any two real numbers a and b, and on adding we get a unique real number from R, and that unique real number is a plus b. Meaning is if we choose any two real numbers R, then their addition is also a unique element of R and unique element of R. The second property, this property is called closure property. Okay, this property is called closure property. Next, commutative law. Choose any two real numbers. Here is a plus b is equal to b plus a. If we change the order of addition, here is first a and here is first b. A plus b equal to b plus a. And if this property is satisfied in set of reals, therefore commutative law hold in R under addition. Okay, this commutative law under addition. I'm here giving just one example. And the commutative law does not hold under subtraction, because 2 minus 4 not equal to 4 minus 2. So subtraction is not commutative in R. The next law is associative law. Here is three numbers a plus a comma b comma c belongs to R, and here is a plus b. Then we add c from right side, and here is a plus b plus c. This law also hold in R, and this law is called associative law. Next is additive identity. Now here is element from R. Here is a unique element from R. If we add this element to any element of R, if we add this element, that is 0, to any element A of R, we get no change in R. Okay, a plus 0 equal to a equal to 0 plus a. This addition of 0 may be from any side. Okay, this is from right side and here is from left side. The result is same. If this result satisfied in R, this unique element is called additive identity. Okay, this element is called additive identity. Next is additive inverse. Choose any element A from R. Okay, choose any element from A from R. We can find corresponding to this element one unique element in R. Okay, one unique element. This unique element is minus a in R, and the addition of these two elements, addition of these two elements is 0. That is additive identity. Okay, addition of these two elements is 0. That is additive identity. This element is called additive inverse of A. Okay, this minus a is called additive inverse of a or negative of a. For example, additive 2 is a real number, its additive inverse is minus 2. Again, minus 3 is a real number, its additive inverse is 3. Okay, so next we are taking the operation multiplication operation. This operation we denote like this. So here is on the similar way as in addition. Here is the closure property. If we choose any two elements from R, their multiplication is a unique element of R. We write like this: take any two elements from R, A multiplied by B belongs to R. Okay, so this property is called closure property. Okay, and the next is a commutative law on the similar way as in addition. So here is a into b is equal to b into a for all a comma b belongs to R. Here is the associative law, a into b and then multiply by c. Okay, a multiply by b and then multiply by c. So it must be equal to b into c and then multiply by a from left side. Okay, so these two results are equal. So this law is called associative law. The next is multiplicative identity. As in addition, we have taken additive identity. Here is multiplicative identity. So this is a unique element from R, 1. This is a unique element from R. And if we multiply any element with 1, we get no change. Okay, a into 1 is equal to a, 1 into a, whether this multiplication is from right or from left. Okay, so this unique element of R is called multiplicative identity in R. Next is multiplicative inverse. So for any element a not 0 belongs to R, there exists 1 over a unique element of R. Okay, so if we multiply these two elements, a into 1 over a multiplied by 1 over a, so we get 1 meaning is we get multiplicative identity. So this element is called multiplicative inverse of A. Okay, this 1 upon A is called multiplicative inverse of A. For example, uh, if we choose 3 by 4, this is a real number, its multiplication is 4 by 3. 3 by 4 multiplied by 4 by 3 is equal to 1. So 3 by 4 is a multiplicative inverse of 4 by 3. Okay, another example, you may take minus 5 by 3. Minus 5 by 3, its multiplication is minus 3 by 5. On multiplying these two numbers, we get identity, multiplicative identity. So these are five properties under multiplication. And here is one more. This is a distributive property. Distributive property, sometimes we call these properties as multiplication is distributive over addition. Okay, multiplication is a distributive over addition, and this first law is called a left distributive law, and this second law is called right distributive law. So here is a into b plus c is equal to a multiplied by b equal plus a into c, and then b plus c multiplied by a from right side. So here is b a and plus bc. So both this law is known as distributive law. Set of real numbers satisfy all these axioms. Okay, so five axioms under addition and five under multiplication, 5 plus 5, 10, and one is here, distributive property. So 5 under addition, 5 under multiplication, and one is a distributive law. The total properties are 11. Okay, the total properties are 11, and R satisfies the 11 properties, and therefore R is called a field. Okay, R is called a field, or we can say that R is a field of real numbers. So here is a order relation in R. These are you know already. If we choose any two real numbers, okay, A and B, any two real numbers. If A is greater than B, okay, we say A is greater than B when A minus B is positive. Okay, A minus B is positive. We say that A is greater than B, and we write it like this: A greater than B, or we can write it as B less than A. Okay, B less than A. We read it like this: B is less than A. Geometrically, if we mark A and B, okay, if we mark these 2 points A and B, then A will be on the right side of B. Okay, A is on the right side of the point, point representing B. Okay, so order relation hold in R. Next properties of order relation in R, they are very easy. The first one is known as trichotomy law. Okay, if we choose any two real numbers, then one and one of the following properties hold. Okay, uh, if we choose any two real numbers A and B, then one and only one of the following possibilities hold. The first possibility, either A greater than B; the second one, A equal to B; the third one, A less than B. Only one property hold here, not all properties. Okay, only either A greater than B, or A equal to B, or A is less than B. So order relation is transitive in R. Order relation is transitive in R. For example, A less than B and B less than C, then A is also less than C. Okay, then A is also less than C, and here is a, if A greater than B, B greater than C, then A is greater than C. So these two uh, properties, they are called transitive. Okay, order relation, this inequality, okay, and this inequality is intransitive in R. So next is order relation is preserved under addition. Order relation is preserved under addition. Meaning is here, if we choose any three real numbers a comma b comma c belongs to R, then if a greater than b, on adding any real number on both sides, okay, I am adding here c, okay, adding c on both sides, there is no change in the uh, inequality. Okay, there is no change here. A greater than b, adding c, we get a plus c greater than b plus c. On the similar lines here, a less than b, adding c on both sides, a plus c is here is a mistake, and this is not greater than, here is a less than. Okay, a plus c is less than b plus c. Next is order relation is preserved under multiplication. Okay, order relation is preserved under multiplication. A comma b comma c, they are real numbers. Then if a greater than b and we multiply with a positive real number, okay, we multiply with positive real number, and to this inequality the sign will be remain the same. Okay, so here is a greater than b. So here is, if a greater than b multiply with a positive real number, we get ac greater than bc. There is no change here. Okay, there is no change in this inequality. Okay, greater than, if here is greater than, here is greater than, when we multiply with a positive sign, positive real number. So here is a less than b, a less than b multiply with a positive real number, we get a into c less than b into c. Here is the result, a greater than or equal to b and b greater than or equal to c, then a is greater than or equal to c. Further, if a less than b, b less than or equal to c, then a is less than or equal to C. Okay, now here are some very easy result. You may see the proof of these results from the book. This is very easy, no problem. Now here is if a greater than b, then minus a will be less than minus b, a positive, then its reciprocal is also positive. Okay, if a positive, then its reciprocal is also positive. If a negative, then its reciprocal is also negative. Now here is a greater than b, c negative. Now here is, we are multiplying with a negative number. Okay, here we are multiplying with a negative number, then this greater than will be changed into less than. Okay, this greater than will be changed into less than. AC is less than BC. Okay, now here is a less than B, and we are multiplying with a positive real number. We are multiplying with a positive real number, then inequality remains the same. Okay, in this less than, here is also less than, AC less than BC. You may see the proof of these 5 results from the book. This is very easy. You may see the proof of all these articles. Article 8, here is 10, here is 11 article, here is 12th, 8th, 10th and 11th. You see the proof of these 3 articles from the book. There is no problem at all. These are very easy results. Okay, so I am taking here between. Okay, so we have 3 real numbers a comma b and c. Any 3 real numbers, if a less than c less than b, or b less than c less than a, we say that c lies between a and b. Okay, if a less than c less than b, and or b less than c less than a, we say that c lies between a and b. So here is a very important result. This is proof that arithmetic average of two distinct real numbers is a real number and it lies between them. Okay, meaning is arithmetic average of two real number lies between them. We are taking here a and b two real numbers. They are two real numbers without loss of generality. So we are taking a less than b. Okay, we are taking these two distinct real numbers. These two distinct real numbers. We are taking a less than b. You may take also b less than a, no problem at all. So here for the proof, we are taking a less than b. A and b two distinct real number. Arithmetic mean of a and b, what is? This is addition of a and b divided by 2. So a plus b by 2 is arithmetic mean of a and b. So we have to prove this arithmetic mean lies between a and b, a less than b. So we have to prove that a less than a plus b by 2 less than b. Okay, we have to prove this result. Now a and b are two real number. Okay, a and b are two real numbers. Their addition is also real number. 1 by 2 is a real number. Their multiplication, a plus b and 1 by 2, their multiplication is also real number. So a plus b by 2 is a real number. So first result, we have proved that arithmetic mean, this is arithmetic mean of two real numbers a and b is again a real number. Okay, arithmetic mean of two distinct real number is again a real number. We have proved first result. Now a less than b, adding a on both side. Okay, we get 2a less than a plus b, and then divide by 2, or we can say that 1 by 2, multiply both side by 1 by 2. 1 by 2 is a positive real number, so inequality will not be changed. Okay, multiply by 1 by 2 both side. 1 by 2 is a positive real number, so this inequality will not be changed. So when we multiply by 1 by 2, we get a less than a plus b by 2. On the other hand, again starting from here, a less than b. Okay, a less than b. Now here we are adding b. Here we are adding b. A plus b less than b plus b plus b. So result is a plus b less than 2b. Multiply both side by 1 by 2. 1 by 2 is a positive real number. So we are multiplying with a positive real number. So there is no change in the inequality. Here is less than, here is also less than. So the result become a plus b by 2 less than b. Okay, a plus b by 2 less than b. So combining these two results, one result is here, one result is here. On combining, we get a less than a plus b by 2 less than b. So we have proved that arithmetic average of a and b lies between a and b. Okay, so here we have proved two result. One result is arithmetic average of two distinct real number is a real number, and it lies between a and b. So it proves the this article. The next we are proving that uh, between two distinct real numbers there lies infinitely many real numbers. Okay, between two distinct real numbers there lies infinitely many real numbers. Here we are choosing a and b two distinct real numbers. Their arithmetic average is a plus b by 2. This is also real number. Okay, so a plus b by 2 between two given distinct real numbers a and b. Again, using the same method. So here is here is a plus b by 2, divide by 2. So this real number 3a plus b by 4 lies between a and a plus b by 2. Okay, sum of the number a plus b by 2, sum of these two numbers, and divide by 2. And this number lies between a and a plus b by 2. So 3a plus b by 2, its calculation is 3a plus b by 4 lies between a and b. okay, lies between A and B. Continuing this process, okay, so up to now we have established uh, two real numbers, one real number a plus b by 2 and other real number 3a plus b by 4. These two numbers lies between a and b. Up to now we have proved this result. Continuing this process, okay, continuing this process, we can show that there lies infinitely many real numbers between two distinct real numbers a and b. Okay, between a and b, two distinct real numbers, there lies infinitely many real numbers, and this property of real number is called dense property of real numbers. Okay, this property of real numbers is called dense property of real numbers. Now here is one problem. Okay, problem: if b greater than a greater than 0 and c positive, we have to prove a plus c over b plus c is greater than b by a by b. So this is given: b greater than a greater than 0. Here is c is a positive real number. So we have to prove this result. We are starting like this. Take this term on left side like this: a plus c over b plus c minus a over b. Taking the LCM, we get b multiply here, b into a plus c minus a into b plus c equal to, on simplifying, okay, on simplifying, we get this type of result: b minus a multiplied by c divided by b into b plus c. So we write this uh, like this: c over b into b plus c multiplied by b minus a. Now b is greater than a. Okay, b is greater than a. Okay, b greater than a. Take a on left side. We get b minus a is positive. So this b minus a is positive. Next, b B positive, C positive, and therefore calculation of this one is also positive. C over B into B plus C is positive because B and C both are positive. Meaning is uh, this is positive, okay, this is positive, this is also positive, this product is positive. When this product is positive, therefore left hand side is positive. Take a over b, here is a plus c over b plus c minus a over b is positive, and take this on right side, we get a plus c over b plus c is greater than a over b. And the next is uh, here is another result: a greater than equal to 0, b greater than or equal to 0. We have to prove that a plus b by 2 is greater than or equal to square root ab. Okay, square root ab with equality holding if and only if a equal to b. Meaning is this equality hold when a equal to b. Okay, this left hand side is nothing but this is arithmetic average of A and B, and the right hand side is a geometric mean of A and B. Okay, you know what is a geometric mean, no problem. So here we are starting, take this on left hand side. So a plus b by 2 minus root ab. Take the LCM: a plus b minus 2 root ab. So we write like this, and this a can be written as square root a whole square, b can be written as square root b whole square. On the whole, this numerator can be written as square root a minus square root b whole square divided by 2. Square root is also always non-negative. This square root is greater than equal to 0. This square is greater than or equal to 0, divide by 2, this is also positive. So the whole result is greater than or equal to 0. So this left hand side is greater than or equal to 0. So a plus b by 2 minus root ab greater than or equal to 0, take this on right side. So we get arithmetic average is greater than or equal to geometric mean. So take the equality. So here we are taking the equality and then cross multiplying and simplifying all these results. We get here square root a minus square root b whole square equals 0. So when this square is 0, the root a minus root b, this is also 0. Take this on right side. Root a is equal to root b, and then on squaring a equal to b. So we are taking here because a is non-negative, b is non-negative, so a equal to b. Okay. The next problem is if x and y they are rational numbers such that x less than y, then x less than x plus y minus x over n less than y. What is n? N is a natural number greater than 1. So we are starting like this. X is less than y. This is given. X is less than y. From here, y is greater than x. Take y on left hand side. Y minus x is positive. Okay. N is greater than 1. Okay. Therefore, n is positive. N is positive, 1 by n is also positive. Multiply this inequality by 1 by n. 1 by n is a positive real number, therefore this inequality will remain the same. Y minus x over n is positive. Adding x on both sides. Okay, here adding x on both sides, we get y minus x over n plus x greater than 0 plus x. Or we can write this result like this: x less than x plus y minus x over n. This uh, result we have proved now. This result we have proved now. Now we will prove the second result like this. Okay. The next one is again y minus x is positive. Y minus x is positive. Natural number n is greater than 1. This is given. Therefore, n minus 1 is positive. Multiply this inequality by n minus 1. We get n minus 1 into y minus x is positive. On simplifying, okay, on simplifying, we get n y into y minus y minus x. Take y minus x on right side. This sign become positive. Okay, and then divide by n. Okay, and then divide by n. We get y minus x is greater than is uh, greater than y minus x. Okay, and then divide by n. Y minus x is uh, greater than n. Y minus x is greater than y minus x over n. Okay, x on right side, y is greater than x plus y minus x over n, and this can be written like this: x plus y minus x over n is less than y. So combining 1 and 2, we get x less than x plus y minus x over n less than y. So here is the last problem today's lecture. This is a very important result. If a comma b comma c and d are distinct real numbers such that condition upon these distinct number is here: a square plus b square plus c square into p square minus 2 into ab plus bc plus cd into p plus b square plus c square plus d square is less than or equal to 0. So this left hand side must be less than or equal to 0. What is we have to prove? A comma b comma c comma d, they are in GP. Okay, these four numbers are in GP. Now this is given, no problem. This is given. So we are writing here uh, a square p square multiply p square inside, multiply by p square inside a square p square, from here minus 2abp, okay, plus b square from here. So we are writing a square p square minus 2ab multiplied by p plus b square. Okay, here we get the first bracket. Now here is the second bracket on similar way, and here is a third one. Here is a b square p square minus 2bc into p plus c square, and the third one is c square p square minus 2cd into p, okay, and then plus d square. So this become ap minus b whole square, this become bp minus c whole square, and this becomes cp minus d whole square, okay, whole square. This is less than or equal to 0. We know that here is a square, here is also a square, here is also a square, and this is a sum. Okay, here is a non-negative, here is non-negative, here is non-negative, and the addition is also non-negative. Okay, because of this reason sum of square of real number is never negative, meaning is sum of squares of real number is always non-negative, meaning is greater than or equal to 0. This result we know, and this result we have established. Combining these two results, we get a ap minus b whole square, bp minus c whole square, cp minus d whole square equal to 0. Okay, so here is a sum of square, here is a square of real number plus a square of real number plus a square of real number, okay, and the sum is 0. Sum is 0. No term is negative here. No term is negative here. But here is the sum. So the possibility is each term is 0. Possibility is each term is 0. Here is AB minus P whole square equals 0. BP minus C whole square equals 0. CP minus D whole square equals 0. So from here AP minus B equals 0. CP BP minus C equals 0. CP minus D equals 0, and from the first result, what is P? This is B on right side, then divide by A, P is equal to B upon A. From here, P equal to C upon B. From here, P is equal to D upon C. So here is P, here is P, here is P, collecting the values of P. So we can write like this: B over A, C over D, and D over C equal to P. Okay, from here we follows that A comma B comma C comma D equal to D. These four numbers are in GP. So this is all about today's lecture. You must work hard, note down today's lectures and other lectures on your notebook. I am very much thankful to you. बहुत बहुत धन्यवाद ਤੁਹਾਡਾ।